Okay, students, I'm going to go over a sample of your practice final here. Yours will look similar to this. You may not have as many problems, but all these types of problems for the school year 21-22. Okay, so notice we have a negative sign. We have to distribute that negative through there. So we're taking the opposite sign. So I have 3a squared minus 8a squared, and 4 minus a minus 9 makes it plus 9. Line up my like terms. 3 minus 8 is negative 5a squared. Notice we're only adding or subtracting, if you want to look at it, the coefficients. The a squared stays the same. And 4 plus 9 is 13. Remember, the only time it changes on the exponent of the a is if you're multiplying or dividing those terms, not on adding or subtracting. All right, number 2, we can combine these like terms first and then distribute the 3x, the a through there. So 3 minus 9 is negative 6x to the 7th, and we have a plus 5. So now we distribute that. 3 times negative 6 is negative 18. 8x's and 7x's is a total of 15x's. And 3 times 5 is 15, and x to the 8th. Number 3, we can memorize the shortcut, which is square the first term, 16x squared. Multiply the two terms together, negative 4x, and double it, negative 8x, and then square the last term, plus 1. Or I can write out the 4x minus 1 underneath it and multiply it out this way, and I have plus 1 minus 4x minus 4x and 16x squared. And I add straight down and I get that same answer right there. Okay, number 4, multiply a binomial times a trinomial. Okay, put the binomial underneath there because then you only have 2 rows to deal with. Oops, that is a minus 9. Negative 3 times negative 7x is 21x. I'm going to put the sign with it. And negative 3 times 2 is negative 6x squared. Okay, I'll change the color for the next row. We have 6x times 3 is 18x. Negative 42x squared. And 12x cubed. Okay, and we add straight down, so we get, I'll change that color as well. 12x cubed, negative 42 and negative 6 is negative 48. X squared, remember, again, when we're adding or subtracting, the exponents do not change on the variables. We just add or subtract the coefficients. 21 plus 18 is 39x and minus 9. That's your answer. Number 5, I ask, is the coefficient of the variable I'm solving for, in this case, x positive? Yes, it is. So I'm going to leave it on that side and move the constant to the other side. So whenever I'm moving an entire term across, remember to add or subtract. So the opposite of negative 18 is plus 18. 18 minus 3 is how I should say that, because I want to say the positive one first, equals 6x. Divide by 6, and I get 15/6. But I cannot leave that there because that simplifies. The GCF of 15 and 6 is 3. So I divide each by 3, and I get x equals 5/2. Or you could say 2.5 if you wanted to. Number 6, again, reverse PEMDAS because we're solving for a variable. Okay, whenever time you're solving for a variable, it's reverse PEMDAS. Okay, if there's no variables involved and all I'm doing is combining, adding, subtracting, multiplying, dividing numbers together, then it's PEMDAS going down. But when we're solving for a variable, it's reverse PEMDAS. Add or subtract first. I'm moving that across because this coefficient is positive. If that coefficient was negative, I'd move the x, or the c term, in this case the other side, and move the constant across. So opposite of negative 4 is plus 4, which of course that is at the bottom level. Remember, when we're adding or subtracting, that is moving an entire term across. Remember, terms are separated by plus or minus signs. So now I'm going to change it to writing it as a half c. 0.5 is 1/2 c equals 10. And then I go ahead and multiply by the reciprocal, which is 2 on both sides. To cancel that out, and I get 1c equals 20 for my answer. Number 7, go ahead and distribute. I get negative 21 plus, minus, come on now. Minus 7x equals 27 minus 5x. Okay, now of course I ask myself which variable is smaller. The -7 is smaller than -5 because it's to the left of -5 on the number line. So I'm going to move it to the other side. The smaller always goes to the bigger side, so therefore I end up with a positive coefficient on the variable. Since the variables are going to the right, the constant must go to the left. So the opposite of plus 27 is minus 27. 7x minus 5x is 2x. Those all cancel out, and -27, -21 is -48. Of course, the last step is divide by 2, which then gives me -24 for my answer. Of course, all these I could plug back in, but I'm saving time when I'm solving for a variable to get through this in a short period of time. Okay, number 8, I'm going to combine like terms first. That's 17. -4x and -6x is -10x. It's just integers. And I have -2 minus 6x. And again, I ask myself, is -10 or -6 smaller? -10 is smaller because it's to the left, so that means I'm going to add the 10x across. So I end up with a positive coefficient. Since I'm moving the variables to the left, the constant must go to the right. So opposite of -2 is +2. And so I have 19 equals 4x. Remember, I should say that's 10x minus 6x. I always say the positive one first. It's easier. Divide by 4, and I get 19 fourths. I'll write that over here. X equals 19 fourths. By the way, I wrote that as a slash. It's actually better to always write it as a horizontal so you get that habit. So that's the better habit, just so you know. It doesn't matter on this particular problem, but on other problems it would matter. And so it's better to always write horizontal fraction bars instead of slashed ones or diagonal ones. All right, number 9, reverse PEMDAS again. We're solving for a variable. Okay, so I'm adding or subtracting first, which means I'm moving an entire term across. Which one am I going to move across? The -4. So now I'm left with x plus 5 over 2 equals 5. The opposite of division is multiplication. So now I'm going to multiply. Remember, this is division bar. So I'm going to multiply both sides by 2 to cancel those out. I'm left with x plus 5 equals 10. And last step, subtract 5 from both sides. And so I get x equals 5. That's my answer. All right, here, remember I have 2 terms. Whenever I have 2 terms in the numerator, 2 or more, not just 2, 2 or more, in the numerator or denominator, I put parentheses around it so do not forget to distribute when I cross multiply. Remember, we're going to cross multiply, set them equal to each other. That's how you solve all proportions. So I'm going to erase that so I can see the numbers now. Okay. So I have, and I'm going to distribute this right now, right away. So I have 8x plus 32 equals 4x minus 8. Again, I ask on the coefficients of the x, which one is smaller? 4x is smaller, so I'm going to move it across. The smaller always goes to the bigger side. Subtract the constant across. Remember, I'm always lining up like terms. You don't put them wherever you want. They must line up underneath the like terms. 4x equals -40. And last step, divide by 4, and you get x equals -10. Okay? Next, again, I ask myself, which one is smaller? The 4 is smaller, so I'm going to move the 4 across. So again, I got to do the opposite, -4x, because I'm moving an entire term across. Remember, whenever you move an entire term across, you're either adding or subtracting all the time. You're never multiplying or dividing for an entire term. Okay, since the variable is going to the left, the constant must go to the right. So 7x minus 4x is 3x, and 2 plus 5 is 7. And last step, divide by 3. So I have x is greater than or equal to 7/3. So at 7/3, it's greater than or equal to, so it's got an equal to sign. It's a closed circle, and greater than is to the right. Okay, and I put an arrow at the end like that. Okay, make sure it's dark, or you can draw the whole thing above to make it clear that it's going like that as well. I don't care either one. Okay. All right, 12. Remember, on the inequalities, just so you know, it always points to the smaller number. So x is pointing to the 7. X is greater than 7. All right, here we got combining like terms. 2x minus 5x is negative 3x. It's just integers, 2 minus 5. And then I have negative 6 there, and I have negative 7 plus 4x here. Now I'm back to the same thing. Which one is smaller, the 4 or the negative 3? The negative 3, so I'm going to move that across. So opposite of negative 3x is plus 3x, which means the constant is going to the right. So the opposite of that is plus 7. Okay, so I have 7x is less than 1. And last step, divide by 7. So x is less than 1/7. Remember, there's no equal sign there, so at 1/7, it's going to have an open circle. And less than is to the left. Okay, 13, solve the system equation by elimination or substitution. If you are much better at one than the other, then go ahead and do that one. I usually always use elimination. Okay, but if you need to use substitution, you can because you have a 1y there. So I could solve that for y by adding the 6x across and have y equals 6x plus 40, and then substitute that in for that y right there. But I like to use elimination. So I can sit there and multiply either the top row by 2. Let's go ahead and do that. I'll multiply this top row by 2 because that's going to give me a 6x, and a minus 6x cancels out to 0. So I'm eliminating my x's, and I have negative 10y plus 1y. Don't forget that. You might put that 1 in there so you don't forget it. Negative 10y plus 1y is negative 9y. And so I'm just distributing this through here now. And then I have 2 times negative 11 is negative 22. So I read that as 40 minus 22, which is 18. And last step, divide by 9. I mean negative 9, sorry. And y equals negative 2. I'm not done. Remember, I'm solving a system. I'm x comma y. So the y coordinate is negative 2, and I need to solve for the x coordinate. Substitute that back in there for the y, negative 2. Okay, so I plug that into the bottom one because it's easy to plug in. 1 times negative 2 is negative 2. Added across makes it positive 42. And so I have negative 6x equals positive 42. Last step, divided by negative 6, and I get negative 7. So negative 7 comma negative 2 is where those two lines will intersect. I could check that by plugging it into the first one to check. Okay, negative 7 times positive 3 is negative 21. Negative 5 times negative 2 is plus 10, and that equals negative 11. And that's exactly what it says right there. So I've guaranteed that it's right. Number 14, y is less than negative 3. 1, 2, 3. Less than, remember, first off, y equals the number is a horizontal line. You know, have that memorized because that means all the y's must be negative 3. The x can be anything. 0, negative 3, 1, negative 3, 2, negative 3, 3, negative 3. It is dashed because there's no equal sign. And remember, it points to the small one. So y is less than. Less than is below. X is less than. So that's also going to be dashed. You might want to write the word dashed. Okay, or dotted if you prefer dotted. And less than is to the left. That means you're going to shade to the left. And x equals 2. All the x's are 2 right here on that line. Every x coordinate is 2, and we're shading to the left. All right, here we have y equals 3x plus 0. So the slope is 3 over 1. Remember, write it as a fraction with the arrows. So y-intercept is 0, 0. Okay, so 0, 0 is my point, and I go up 3, right 1. Up 3, right 1. I could go down. Remember, I can also write this as negative 3 over negative 1, which would be down 3, left 1. Okay, and there's my line then. And that would be dotted. Let me see if I can switch it to dotted right now. Let's switch it to dotted. Oh, no, I'd have to start again. All right, I'll start again. Delete, dashed, and I want that one. Okay. Oops. I took it off by doing that. Okay. So there's my dash, and I can go ahead and put on the arrow on the other end. Remember, I gotta have arrows on both ends to make it a line. Without that one arrow there, it would have been an array. If I have neither arrow, it's called a segment. You need to know that for geometry. All right, the second one. 2x I can say 1 point is if x is 0, remember that's the standard form. If I plug x is 0, then y would be -4. So 0, -4 is on this line. Now, if I solve for x, I get 10. Well, I can't graph out to 10, so I'm going to have to do another point. So let's say I go ahead and I just do an x, y, t chart, and let's say I make y equal to -2. Okay? So I have -5 times -2 is +10 then, which then when I subtract that across, I'm subtracting 10 across, which makes it 20 minus 10 is 10, and 2x equals 10 is 5. So 5 -2 is another point on the line. Okay, so now I go ahead and take and this one is greater than or equal to, so it's solid. So I need to pick the solid one. Okay, and then again, put the arrow on the other end, so it's a line. Okay, now I look at it, it says y is greater than this one. When it's in slope-intercept form, I go with the inequality exactly as it is. So greater than is either in this quadrant region right there or that one right there. Those are both greater than that line. This one says greater than, but I have to look at when it's in standard form, I have to look at the coefficient of the y. That's negative, so that means I have to switch the inequality sign. So it's going to be less than, so it's either going to be, I'll change the color, it's going to be down here or down here. That's both below that line. Well, where do I have both dots? I have it right here in this region. So this is the answer, this region right here. These other two only have a single dot. That means it only satisfies one inequality or the other. Only this region had two dots, which means it satisfied both inequalities. I could also pick a point in there to check, and if it works on both inequalities, it's going to be true, and that would work. Okay. All right, next, we want to find the average. We want to find the x value. What's the last test score, or whatever these are, doesn't matter what they are, so that it averages to be a 12. Another word for mean is average. You need to know that. So 7 plus, so that means I add them all up, and divide by the same number there are, which is 5. That has to equal the average, 12. So 14 and 12 is 26, and 20 is 46, plus x divided by 5 equals 12. Okay, reverse PEMDAS, the opposite division. Remember, that's a division sign. So the opposite is multiplication. So I'm multiplying by 5 on both sides. So I have 46 plus x equals 60. 46 plus what number is 60? That's 14. I subtract the 46 across and I get 14. There's my answer. Okay, graphing here, 2x minus 1. Again, I have my slope of 2 over 1 up to right 1. Y-intercept is 0, -1. 0, -1 is a point. And I go up to right 1, up to right 1, up to right 1. There's my line. Arrow on the other end, so I don't forget. So it's a line. If you leave those off, you lose a point. Okay, you cannot forget your arrows. Okay, here it says y equals -2. Now, don't forget the slope is positive. That means it's got to go up and to the right to be positive. Notice this slope is negative, so it better be going down, left to right. So this says the y-intercept is 0. If there's nothing there, it's 0. So 0, 0 is the first point. There's my down 2 and right 5. Down 2, right 5, right there. Okay, and arrow on the other end to make it a line. Okay, now I have standard form. Remember the two easiest points to plot in standard form of the x and y intercepts. X-intercept means solve for x. So y is 0. Y-intercept means we want to solve for y. So x is 0. Okay, so if y is 0, cross that out and you get 2x equals 6, x equals 3 for the x-intercept. For the y-intercept, x is 0. So cross that out, you get 6y equals 6, y is 1. There are 2 points right there, 3, 0 and 0, 1. So if you're good with your integers, boom, you can do that right like that. You have that. You can always solve for y. Since that's positive, I'm going to leave it there. So I have 6y, subtract the 2x across, minus 2x plus 6. Divide each term by 6, and you get y equals, and you always reduce that, -1/3 x plus 1. Okay, so notice 0, 1 is right there, and it says go down 1, right 3, and that's my second point. But obviously in solving for that y, there's more chance for error in your math. So that's why we don't recommend it unless you're not confident with your integers. Put the arrows on both sides, both ends of it. All right, now we're solving the system by graph. Remember, solve systems, I got to come up with the point. Negative is a positive. Then I need to move that across, so it becomes -6 over there. This is a negative y, so I'm going to move it across, which means I'm moving that across. So then I'd have y equals x minus 2 for the second equation. When I move that 2 across, it becomes -2. Remember, whenever you move an entire term across, you're doing the opposite operation. So the first equation, y equals -3x minus 6. There's minus 6, -3x. -3 slope, that could be down 3 and right 1, but if I do that, that takes me off the graph. So I'm going to switch and put it 3 over -1, which means up 3 and left 1. So I'm going to go up 3 and left 1, up 3 and left 1, up 3 and left 1. I'm just going to leave it like that right now. Okay, and then I have y equals x minus 2. Y equals x minus 2 right there. Minus 2 is the y-intercept, and the slope is 1, which means up 1, right 1, or down 1, left 1. Oh, look at it. Intersects right there at that point. Okay. If I had a ruler, it would have been straight. Okay, so there's -1, -1, 2, 3. -1, -3 is where they intersect. Okay. I could plug that -1, -3 into both those equations and it'd be true. All right, here we have box and whisker. All right, from the data and fill it in. I already went ahead and arranged it from least to greatest for you. Okay, but if it was not in least to greatest, you'd have to do that yourself. I have a total of 7, so the fourth one is the median. Remember, another word for median is the Q2. I'm just testing here and make sure you know both those. Q1 would be take the middle number of the bottom half, which is 5. Take the middle number of the top half, which is 13. The IQR, interquartile range, that is Q3 minus Q1. So 13 minus 5 is 8. The range means high minus low. Gotta know that. So that's 39 minus 1 is 38. And the out mode means the most. Which one occurs the most? 8 does. Outlier, remember that is 1.5 times the IQR. So IQR is 8 times 1.5 is 12. After I get that number, I do Q3 plus 12. So Q3 was 13. 13 plus 12 was 25. So anything greater than 25 is an outlier. 25 and up is an outlier. So notice 39 would be an outlier. The other direction is I go Q1 minus that 12. And Q1 was 5. And so 5 minus 12 is -7. Anything less than -7 would be an outlier. Well, 1's our lowest, so it's not even there yet. Okay. Since I use that up, I'm not going to draw the box and whisker. I'll squeeze it in here. 1 goes up to 5. Draw my box. Q2 is 8. Q3 is 13. And the high is 39. Okay, that's how my box and whisker would look like. All right, 23. Says what percentage of the data in plot A, here's plot A, is above 70. There's 70. Remember, each grouping is 25%, 25, 25, 25, and 25. So above here is 50%, which is below 60 in B. There's 60 when it's below. That's only one group, 25%. Okay. Number 24. We're going to, this is a slope of -1. All those are in order. Right in order nicely, -1. This is pretty close, so that's -0.8. This is less close, it's -0.3. This is chaos, 0. This is It's not real close, but it's positive slope, 0.3, I mean. This is closer still, so 0.8, and this is right on line, so it's a 1. You were to take these numbers right here and match them up underneath their graphs on the correlation coefficient. Remember, that's the R we found on the graphing calculator. If it's -1 or +1, all the data are lined up perfectly in a line. Okay, that's what that means. All right, number 25. Kelly makes $7 an hour babysitting, $11 an hour giving music lessons. She works 11 hours. So babysitting plus music equals a total of 11 hours. And makes $97. Well, she makes $7 for babysitting plus $11 for music, and she makes a total of $97. So now we have a systems of equation. We solve it. I'm just going to go with a smaller number. So I'm going to multiply the top row by -7. So I get -7b plus 7b is 0, -7m. So I have 11m minus 7m is 4m. And I have 97 minus 77 is 20. So m equals 5. So music is 5 hours. And then I knew 5 plus what is 11. Babysitting is then for 6. 5 plus 6 is 11. Okay. All right, write an explicit recursive formula. Remember, find the following sequence. I gave you a hint already. D for the difference. How do I get from -8 to -14? I'm subtracting 6 each time. So -6. A sub 1 is always the first equation, and that's the first term, -8. A sub n, the current term, equals the previous term, written a sub n minus 1. The previous term is -8, and how do I get to there? I subtract 6 each time. Remember, on that one, you have to keep using the previous term to get to the next term, whereas the explicit formula, I'm allowed to go right to any term I want. This setup is always going to be what? D times n minus 1 plus a sub 1. Or I can think of it as slope-intercept form where I have y equals mx plus b, but remember that b is the 0 term. The 0 term, remember, this is the first term. So if I want the 0 term, I have to go back 1 to get the 0 term, and I'm going to do the opposite. I'm going to add 6. So -8 plus 6 is -2. So I can use the slope. There's -6 is the slope, -6n, and then the first one was -8 plus 6. I mean, the 0 term is -2. Okay, that's the 0 term of the y-intercept right there. And that's the slope. So it's like y equals mx plus b, but we're using the variable n instead of x. Now I could have also written it as it says d there is -6, and then I have the quantity n minus 1, and then a sub 1 is the -8. These two are the exact same. If I distribute the -6 through there and combine like terms, I'll get the top one. All right, here we're multiplying by -4 each time. So the ratio, remember, ratio is what I multiply by to get to the next number, -4. Recursive formula, again, always a sub 1 equals the first term. The current term equals what? Well, I'm going to take the previous term, which is a sub n minus 1, and multiply it by -4. So if I'm multiplying by that, I'm going to put the -4 out front. If I'm adding or subtracting, I'm going to put the add or subtract at the back, like we did over here. The explicit allows me to go right to it. Remember, that is a sub 1 and then r to the n minus 1. So a sub n, this is for the geometric sequence. Remember, if we're multiplying to get the next term is geometric. If we're adding or subtracting, it's arithmetic. So the current term, remember, that's a sub n, is called the current term, equals a sub 1, which is -4. The common difference, or the ratio is -4, and it's to the n minus 1 every time, and you're done. There's your answer right there. Okay, so I gave you the setups right here. These are the setups right there, and then I fill in the numbers below it. I could have written either one of those formulas, either one of these formulas. They have both of those written on the DCAS. You need to know both ways. So if you write like right in the bottom one and you don't see that answer, you need to distribute through to get the top answer. Okay. We will do these calculations on the calculator last, and we'll do them in class. All right, here we go. Horizontal, vertical, oblique, or not a line. Remember, I look at the exponents on the variables. Remember, in order for it to be a line, the variable has to be in the numerator, and the exponents have to be 1 only. Or you can have a 0 because anything to 0 power is 1. So if I have both an x and a y in the equation, it's automatically oblique. Here, remember that's x to the 0 is 1, so it really just says 4. So really I just have a y. Y equals a number. I can solve for y. I have y equals a number. Y equals a number is a horizontal line, 1. Now here you might say, oh, the variable x is down in the denominator. But remember, this is a negative exponent. Negative exponent, how do you make it positive? If it's in the denominator, you move it up. It makes it positive. So that really says 4x now. That's what that says, 4x minus 6y, which is now just like number 1. So it's oblique. Number 11, the GCF, greatest common factor. First, I look at the numbers here. What's the GCF of 10 and 20? 10 is the biggest number that goes into both of them. Then I take the smallest number of the variables. Well, they both have 5 in the x's, so I can take all 5 of them out. But for the y's, the smaller is the 5. I can't take 6 out because the left term only has 5 of them. They both have 5. One just happens to have one more than 5. It has 6, so I can take 5 out of both. All right, number 12. When I multiply fractions, I cross cancel. And so that's 3 halves right there. Plus, remember we do PEMDAS going down this time because there's no variable in it. Okay, so I'm going PEMDAS down. There's no parentheses, no exponents, so I'm doing multiply and divide left to right. So I just did multiplication. Now I need to do my division one right here. Then lastly, I do the plus. So division, remember, is multiplication by the reciprocal. So multiply by the reciprocal. Now I do my cross canceling. 4 into 16 is 4. 6 into 18 is 3. So then I get 3/4. So now I have 3 halves plus 3/4. Remember, when I add fractions together, I need to get a common denominator of 4. Well, I had to multiply this by 2, so I got to multiply the numerator by 2. So I have 6. Change the color. 6 for the first one, and then notice I didn't have to change the second at all. It's already got a 4 there, so the numerator stays the same. 6 plus 3 is 9/4. Okay, got to see the work. All right, number 7. The degree. I look at the highest exponent, the degree on each exponent, on the variable, not on a number, only on the variables. So notice I only circled 4 of them, not all 5 terms, or there's 5 terms here, because that 8 on the 7 it's not on a variable. It's on the variable. So the highest degree here is 6. So the degree is 6. Standard form is to write from the highest degree down. So I have to put it in the highest degree down. Negative 4x to the 6th. The next one down is 4th. So 3x to the 4th. The next one down is 3rd. Negative 8x cubed. Negative times negative is positive, so plus 5x squared. And lastly, the minus 7 to the 8th. Okay. Number 8, when I have multiple variables in it, I add those exponents only on the variables. So 2 plus 2, that's a 4th degree one. 6 plus 1, 7. And then that's just got a 4. So the highest degree is 7. In the standard form, again, I write highest degree down. So negative 2x to the 6th y. Next one is, okay. They're both 4 there in this case. So in that case, you technically can put either one. 3x squared y squared, and then plus 2x to the 4th. Okay, they're both degree 4. All right, number 13. I need to factor out what this is really asking is what's the GCF. So I look here, I see 13x squared. I find the x squared term up there, negative 52. So if I go negative 52 x squared divided by 13x squared, obviously the x squareds cancel out. Negative 52 divided by 13 is negative 4. So that's what they have taken out. Okay, they divided each term by negative 4. I could have looked at that. and then done negative 16 divided by positive 4, because those are the like terms. That gives me negative 4. Or I could have gone 8 divided by negative 2, because those are like terms. That gives me negative 4. That's what they took out of each term. So that's GCF. Okay. 9. Function notation. Here's my f of x, g of x. I just substitute that in there. So I'm just, and this is just add. I already have them lined up. 4x squared plus 3x squared is 7x squared. That's a minus, and that's a minus. So negative 4 and negative 3 is negative 7x. And that's a plus down there. That's a 6 minus 4 is positive 2. Very simple there. Now, 10, you got to actually write it out and multiply. So I have 4x squared minus 4x minus 4. 3x squared minus 3x plus 6. And now I multiply negative 24, negative 24x, and 24x squared. Change the color for the next row. Okay, negative, that's positive 12x. Negative times negative is positive. And there's another plus 12x squared. And then negative 12x cubed. And then change the color for the last one. 3 times negative 4 is negative 12x squared. And I have negative 12x cubed. And I have positive 12x to the fourth. I can fit that in there. So I have 12x to the fourth. Now I'm just adding straight down. Negative 12 and negative 12 is minus 24x cubed. And then I have this 12 minus 12 cancels out. So I'm left with 24x squared. And then I'm left with 12 minus 24 is negative 12x. These are just integers. All this is just integers. Multiplying and adding your integers. Okay. So there's that answer. Number 15. 14. I need to multiply these two together first, get that answer. Okay, and then multiply it by the 3x minus 1. So I just showed you multiplication just to save time in this video. I won't go ahead and do that. 15, slope. Remember, slope is changing y over changing x. The long way of writing that is y sub 2 minus y sub 1. Oops, y sub 2, not y squared. Y sub 2 minus y sub 1 over all over x sub 2 minus x sub 1. So, doesn't matter which order I go, I like to make the numerator positive. So 6 minus a negative 6 will make it a positive 12, and negative 8 minus 4. Okay, so that equals 12, because that becomes plus, over negative 12, which equals negative 1. I would do the same thing here. 6 minus 4 is 2, and negative 6 minus a minus 8 makes it plus 8. So negative 6 plus 8 is positive 2, and that equals positive 1. Okay? We will do this in class 1, 2, and 3 because that takes too much time to show on the video here.